All right, so like I was saying before, Math 9, we did things like, let's say like 2x plus 3x, and some people already told me there that would be like 5x, right? So we're dealing with this like there's variables within this. They're called like polynomials. So we're learning some skills to deal with these polynomials. This is going to be a huge, this lesson right now we're going to be doing is called factoring. And this comes up if you guys take the more academic maths as we go on. This factoring is going to be a huge skill, right? Like if you're able to do this, it just comes up all the time. And then we're going to do harder things, and it's just assume that you guys know how to do this factoring. So this is a pretty important one to kind of get your brain wrapped around for future years. Okay, so let's start out with one that we did last year, and that was this. So let's say if we had 5 times x plus 2. I know it was a long time ago, but the way that this would work is this is 5, and then in brackets x plus 2. This is what's called a monomial times a binomial, one term and two terms. But either way, do you remember how we did this with this rainbow? How I go 5 times x and then I go 5 times 2? So the way that we do that would be 5 times x is, well, you can just write that as 5x. And then 5 times 2 was positive 10, so that was just plus 10, right? Now what this factoring is actually just going in reverse. So if we were given something like 5x plus 10, then you would know how to actually change that back into 5 times x plus 2. It's going the other way. So, and the reason why it's called factoring is because I actually have two factors out of this. So we've done a bunch of stuff with factors, right? Like what are all the factors of a number? Well, here's my factors of a polynomial. We've got 5 as one factor, and the other factor is x plus 2. Factors are things that are multiplied together. So the factors, remember, of 6 would be like 2 and 3. 2 times 3 are the factors. With a polynomial, the factors are going to look different. It would be 5 and x plus 2. That kind of makes sense? So that's where we're headed. Okay. So, polynomial is defined. So, polynomial is an algebraic expression formed by adding or subtracting terms. For example, it could be x plus 5 is considered to be a polynomial. 2d minus 2.4 is a polynomial. 3s squared plus s, or plus 5s minus 6 is also a polynomial. So, the word poly means many, and nomial means term. So it's really just saying like many terms. Like polynomial just means more than one term. Yeah? Okay. So actually I shouldn't say more than one, because we also could have what's called a monomial, a binomial, or a trinomial. Okay, so those are all types of polynomials. You can keep going up. You could have like 4, 5, 6, but a monomial is one term. So that would be something like 3x squared, right? That's a monomial. It's one term. Okay? A binomial would be something like 3x squared plus 2x. That has two terms. Remember how terms are separated with an addition or a subtraction sign, right? Like this would be a term and that would be a term. So that's a binomial. You're probably seeing where we're going with this. A trinomial would be something like 3x squared plus 2x plus 4. That would be a trinomial because there's 1, 2, 3 terms. Good? All right. Well, actually, they're all types of polynomials, but after 3, we just kind of say like degree 4. We don't really like keep going with the names. Okay. Greatest common factors of polynomials. So last unit we were doing greatest common factors of just like large numbers, right? Now we're going to be doing greatest common factors of polynomial expressions. So those are going to look different. Our answers might look like, 3x squared or something. It's going to have a variable in it. So just as a bit of review, what is the greatest common factor of 72 and 48? We probably don't need to break this one down into its primes to find it. 72 and 48. So I just asked myself off the bat, what numbers go into 72 and 48? What's that? 2 does, but it won't be the greatest. There's actually a bigger one that goes in. Well, and there's actually a bigger one. 8. What about 8? 8 works, right? 8 goes into 72, and 8 goes into 48. 8 times 6 is 48. 8 times 9 is 72. Right, so greatest common factor there would be 8. What about this one? 14 and 42. The greatest common factor there would be 7. Yeah, 7 goes into both. And you want to take the biggest one if you can, right? Okay, this one, identify the greatest common factor of each pair of terms. So now, I'm just going to write this one again so it's clear. We want to find the greatest common factor of, let's say, 6 to the 1 and 6 to the 3. Okay, so just to see this a bit more clearly, 6 to the 1 would really be just 6. And 6 to the 3 is 6 times 6 times 6. So just 6. The greatest common factor here would be what's common to both, right? So that's just 6 to the 1. Yeah, so that would just be 6. And then 8 to the 4 and 8 to the 7. Anybody know, just from like our last example, what would that be? Not just 8.
8 to the 4.
Yeah, it'll be 8 to the 4. 8 to the 4 would be common. It's the smallest exponent when we start talking about exponents. And it's worth writing out here just so we know. 8 to the 4 would just be 8 times 8 times 8 times 8. And 8 to the 7 would be 8 times 8 times 8 times 8. Okay. And then we can see that 8 to the 4 is in fact common to both of them, right? It's common to that one and common to that one. But when we're just looking at the exponents, you can kind of quickly see it's just the smallest exponent is going to be common to both of them. So in this next one, what would the greatest common factor of x to the 5 and x to the 2 be? X to the 2, smallest one, right? It's got to go into both. Yeah, so x to the 2. Okay. So then we'll just do it again. Identify the greatest common factor of x to the 5 and x to the 7 would be x to the, x to the 5. Okay, now we can do it with numbers and letters. So when I say identify the greatest common factor of 12x to the 4 and 8x to the 3, let's just do the numbers first and then do the variables second. So what's the greatest common factor of 12 and 8? 4, yeah. So 4, and then what's the greatest common factor of x to the 4 and x to the 3? X to the 3. So there's my greatest common factor, just 4x to the 3. We're going to be using this in a minute. We'll have a reason there. Okay. So now let's just keep going because they can just be a little bit more complicated. What's the greatest common factor of 5m squared times n and 15m squared times, or m times n squared? So just one at a time, right? Just do the numbers first. So what's the greatest common factor between 5 and 15? 5, right? So 5. What's the greatest common factor between m squared and m? Yeah, just m. Or m to the 1, same thing. And then what's the greatest common factor between n and n squared? Just n. There you go. Okay, this one looks more confusing, but it's still not too bad. What's the greatest common factor between 48 and 36? Yeah, 6. And then we'll just do the a's. So this a is just a to the 1, and that's a to the 2, so just a. And then b to the 3 and b to the 2 is going to be b to the 2. And then c and c to the 2 would just be c. There you go. That's our greatest common factor. Okay. Now, we're going to use that. So you guys can look at this, like example 2. It kind of is going to do the same thing I'm going to do. But let's just do some examples because I think that's where we can figure this out. Now, this looks super confusing, right? Looking at this one. It's not actually too bad though. When we want to factor this, what we want to do first is we want to factor out the greatest common factor. Okay? So here's what we're going to do. We are going to figure out the greatest common factor between this term, and this term. All three of them, right? So I'm thinking first off, what's the biggest number that goes into 27, 18, and 36?
9.
Yeah. So 9 would be the biggest one, right? So here's what we do is we just write down the 9 first. So 9 is the biggest number that goes in there. And then we're going to say, okay, what's the greatest common factor of the r's?
R.
Yeah, this one is just r by itself. So that's going to be just r. And then s would be s to the 2. Okay? So what we just did here is we factored something out. We found out what's common to both, right? That's the thing that's being that we're going to multiply by. That's one of our factors. Okay? So then the next step we're going to do here is we're going to start a bracket. And then we're going to write what's left, right? So what we're going to do is we're going to say, okay, this 27, I had to divide that by something to get the 9 out. So that's going to be a 3. So 27 divided by the 9 I took out would be 3. And then r divided by the r I took out would be what?
1.
Yeah, r the 1 you mean?
Yes.
Yeah, just r, right? And let's just pause on that for a second, just because I know that might be confusing. What we did here is we went r squared divided by the r I took out. That would just be r, right? 2 minus 1. We subtract exponents, right, when we divide. So that's going to be what we're doing with exponents whenever we do these things, is we're going to be subtracting the exponents, right? So like 2 minus the 1 we took out is 1. Let's do more. I think it'll make sense as we do more. It's kind of just getting the hang of it. So now this one, s to the 2 divided by s to the 2 that we took out would be like s to the 0, but that's really just 1, right? Anything to the power of 0 is 1. So that makes sense. We like divide the whole thing out, so we don't have any more s's in this first term. Okay, move on to the next term. So now we're just dealing with the 18.
But you
8.
don't need to put the S?
What's that?
You don't need to put the S down?
No, I could put like the number 1 if you like, right? Like there's like, because really what we did here is we went s to the 2 divided by the s to the 2 that we took out.
So basically you just canceled.
We just canceled it essentially, right? You just canceled it, yeah.
Okay.
Okay.
Good suggestion.
Okay, and then move on. So just leave this for now just as a negative, right? So it's going to be, or minus. So minus, and then we just do the next one, right? We're just going to do it to all 3. So this 18 would become what? 2, right? 18 divided by the 9 that came out was a 2. And then r to the 2, right? Because it's like 3 minus the 1 is r to the 2. And then what happened to my s? It's gone too. And then I move on to the next one. So minus 36 divided by the 9 we took out was 4. What about an r? Yeah, I don't have it anymore, right? It canceled. And then s to the 1. Close your bracket, and you're done. Okay. Okay. And I think it's worth going the other way for a second because I want to show you like how it works going back now, right? So if I expanded this, right, it would be that times each of those terms, right? Well, if we went back, that would be 9 times 3 is 27. R times r is r squared. S to the 2 times, well, 1, or it's just going to be there, just s to the 2, right? There's my first term. Minus 9 times 2 is 18. R times r squared is r to the 3. And then s times nothing there, times 1 is just s squared. And then minus 9 times 4 is 36. R times r, or no, r times nothing right there is just r. And then s squared times s is s to the 3. Right? So it's just going back and forth, right? We just expanded and then factored. They're just the two sides of the same coin. All right. So I'm going to pause it. Can you guys do this one? All right. So there's your answer, guys. Like you're probably noticing, a big part of this, like being good at factoring, is like attention to detail, right? Like just not like not screwing yourself up where like you all of a sudden divide the exponents instead of subtracting, or like there's just lots of little ways that you can make a mistake. So you just gotta like really try to focus in, pay attention as much as you can, because there's lots of places to make a mistake. It's all simple math, but just easy to make mistakes. Okay. Okay, so now, that was one style of factoring where we had, where we just factored like a monomial out, right? Like that's a single thing that we factored out. Oh, by the way, now that we've done this, how many factors do I have sitting here? I'm glad I asked. There's only 2. And here is a factor, right? That's one factor. And there is a factor. There's my second factor. Because factors are just like something times something else. Before it was like 2 times 3. Those were my factors. Now my factors just look way more confusing. But this is still just this one times that whole trinomial, right? That big thing. But those are still the 2 factors I have. Okay? So now it can also be, instead of just a monomial like in the last example, it could be a binomial or a trinomial or anything else that we factor out. So let's do an example. Again, I think you can look through these examples. It shows you how to do it there. But I'm just going to start off with these 2. So what if we had 4 and then x plus 5 minus 3x and then x plus 5. So the key here is that both my underlined parts here, like in red, they're exactly the same. You guys see that? Like those are in brackets there? Yeah? So those are exactly the same thing. And what I'm going to do for a second, instead of writing it like that, let's write it like this. If I had 4, and then instead of an x plus 5, let's just for a second call that a. And call that one a. I just want you to see what's happening here. So instead of an x plus 5, I'm just going to write that as 4a. Okay? And then minus, oh, that's a different color. 3x, and then times a. Right? I'm just doing that for a second. I'll show, it'll make sense why I'm doing that in a minute. Now, from what you guys just learned in the last part there, like looking at this one, do you see that a is common to both of those? So couldn't I just factor out an a? I could just like, you could say a is the greatest common factor there. So I could say, okay, well, one factor is a, and then I could start my bracket, and I'd be left with 4 minus 3x. Right? That's all we really did there. But remember what a was? A was really x plus 5. And then 4 minus 3x. Do you guys see what happened there? No? Okay. Okay, so that's really the idea here is we're just factoring out the common thing. Maybe let's just actually look at it. Let's look at it like the original here instead of changing it to an a, because I don't know, sometimes I think that helps people think about it, maybe not. Do you see how like x plus 5 is common to both of these terms? Like if this was a term and this was a term, x plus 5 is common to both of those. Okay, then let's just do what we did before. The common factor we just write down. So x plus 5 is the common factor. So I'm just going to write that down first. And then I'm going to start a bracket and then write what's left. So after we divide out x plus 5 from both of these, all we have left is the 4, right? Because this is gone. And then minus 3x because that's gone. I divided it out on both of them. Do you guys kind of see that?
I got it the first time. Seems way harder.
Seems way harder. It's tricky. Yeah, it's a little trickier to think of. Like I get that. Yeah. So okay. So that's the idea there. Now we're, instead of the situation where we have it set up this way, where we've got x plus 5 already in both of those terms, like already separated. Sometimes, and when we do some harder factoring ones, we have to do that ourselves. And the way that we can do it, watch this. This is neat. We're gonna do what's called factoring by grouping, where we are just gonna factor the first 2 by themselves, and then factor the second 2 by themselves. So just, well, I guess what I'm saying there is just ignore this part of it for a second. We're just gonna factor this one. So if I was factoring this one, what's common here? What's the greatest common factor of a squared and 8ab? Just a. A is the only thing common to both. So we're going to say, okay, it's a. And then we start a bracket. And then what do we have left? It'd be a plus 8b. b. And then close your bracket. Okay? Now we're going to do the back side. So now we'll just ignore this for a second. Let's do the back part of this. So what's common to 2a and 16b? Just 2, right? Just the number 2 there. So we're going to factor out a 2. So it's going to be 2. And it's going to be like a positive 2, you can think of it. So I'm going to put like a plus sign there. And then we're starting a bracket, and we're going to have left a plus 16 divided by 2 is 8b.
So that's 8 plus...
Do you guys see what happened there?
Yes.
A plus 8b, a plus 8b, those are the same. So then our factor here, right, is going to be a plus 8b, right? That's the common factor. And then what's left is a plus 2. Can you guys kind of see the pattern? Like, I know I'm kind of showing you why, right? Because we're factoring out this a plus b and everything. But can you see the pattern here? That one of the factors is going to be the one that shows up twice. And the other factor is going to be what's left. Yeah, so you can kind of see it kind of quickly once you kind of get that pattern.
So we don't have to solve these answers?
No, well, this is it. This is an expression. These don't have a solution. This is actually going to be true. Like, you can put any like number you want in for a and b now, right? That could be 3. That could be 5. So this is like an equation for like a bunch of...
Oh, I thought we'd have to like solve this down to like the
You're not going to get a number for an answer because this is an expression.